conversation. Oh, yeah. Good. Whoa. That's a good time waiting to happen. So you can't hear anything. Do we just go back to your speakers over there? Yeah? Wait, now it's on? So should I just keep talking and seeing, test? All right, so we are live. Can you turn the music off? Ready? Woo! We have 4 amazing speakers tonight. We normally have 3, so let's get rolling. Thank you. All right, all right. So thank you so much for being here. It is beautiful outside. I have no idea what the weather is going to be like for the rest of the week, but you guys are investing in yourselves and in your colleagues by being here, and I really, really, really appreciate it. Thank you. Enjoy the beer. I also want to say thank you to our other organizers. So I'm Tony, and this is Justin, this is Greg, and we also have Jennifer and Eric, who are not here tonight, but wave to them on the screen, even though they can't see you. Also, really want to give a shout out to Galvanize. They let us use this space. This is the only space that we haven't quite been able to outgrow. We've been doing this for almost 5 years and really went through a growth spurt there, and Galvanize is now our home. And so we really, really appreciate them. If you're not already familiar with them, they have a data science track. All 4 of our speakers are from the data science track, I believe in Denver. So get on their mailing list. They have a lot of meetups. They have a lot of things going on. We are by far the best meetup, I'm just gonna say, but you know, there's other cool stuff going on out there. So tonight, we have Ed White, who is starting off talking about classifying mountains. After that, we have Amber Rivera, who is going to be talking about predicting home improvement, green or not. After that, we have David, and I should have practiced your name. Hold on. Henslowitz? Yes. Who will be talking about modeling lung cancer. And last but not least, we have Sarah Lewis, who is going to be talking about mountain bike trail finder. All right, so you guys have all been thoroughly enjoying the beer, is that right? Yes. So I have a sad announcement to make. Vindication has been with us through most of our 5 years, but as of April 28th, their location in Gun Barrel is going to be shutting down, which means they are no longer going to be supplying our beers. So please enjoy the rest of the stout that we do have. And I highly recommend going to Gun Barrel for their closing ceremonies, if you will. There's going to be a whole lot of fun going on. And anyone, I already see that there's some money in the tip jar. Thank you so much. You keep the beer flowing. And where the beer flows, new people show up. So keep it going, and thank you very much. All right. So I'm assuming that there's a lot of newbies here tonight. Who's new? Who's never been to an Analyze Boulder before? Awesome. Take a picture of this slide. We all love each other very much. This is an awesome community. And we stay in touch in between our actual monthly meetups. So get on our Slack channel. If you're looking for a job or you're offering a job, get on the LinkedIn channel. Feel free to announce things at any time. And of course on Twitter, take pictures tonight, make comments tonight, all that great stuff. I see some Galvanized people here. Do you want to make an announcement? You missed our thank you. After? Okay. Sweet. Well, this is technically our announcements part. Do you want to kick us off? Yeah. Are you Danielle? Yes. Awesome. Danielle!
Hi, everyone. I'm Danielle. I'm the community coordinator and event coordinator here at Galvanize. So I just wanted to welcome you all. Thank you for coming here. I want to tell you a little bit about what we do. We have co-working space, so you guys are sitting in the open area for the Galvanize co-working space. We have web development program, data science program going on upstairs, and event space. So real quick, we have have some really cool events coming up. In May, actually May 10th, we have Founder Hour, where Kim Jordan, the founder of Celestials, or not Celestials TV, that was last month, founder of New Boulder Brewery, will be in the gallery, so try to hit that. We also have a hackathon going on this month. I hear there's like $10,000 worth of prizes throughout that weekend.
Awesome.
So registration is still open. That's going to be April 28th through 29th. AUVSI will be hosting that. So yeah, I just want to welcome you guys in, and thanks for being here.
Awesome. Thank you. Yeah. Woo! All right. Who has any other announcements for events or awesome meetups going on? I'm going to start with Lloyd, and then we'll go over to Taryn. Oh, thanks.
Hey, I'm Lloyd.
Sorry. I can. Yeah. Are you comfortable? I started to think like maybe you weren't comfortable with it. So.
Technology. So we're doing access to national security capital, national security.
Nice. There was that much money.
We'll get day of paintball and barbecue with Green Berets, and special forces. Well, we put it this way.
Awesome.
There's a fire factor. You can find us at 55.net.
Awesome. Woohoo! No, perfect. All right, Taryn.
Hi, I'm not going to breakfast for a long walk. That's okay.
Yeah.
I am Tara, and the lead data science instructor here. And if you enjoy this event tonight, which I suspect you will, I've seen all these presentations before. And so if you want to see more presentations just like this, in just less than 2 weeks, Tuesday, April 17th, we are having a capstone event for our graduating data science cohort here. So there will be 9 flash talks on super interesting data science topics. We'll be right here in the same space. If you are more interested, let me know, and I will try to send the information to you, and hope to see you there.
All right, awesome. How many of you are actually students? Sweet. Okay, cool. Thank you for coming and supporting other these students, I should say. How many of you actually stay up at night thinking, what on earth am I going to do with my career? What is that? That's your worry. Awesome. Like all of us, right? Hackathons are a really excellent way to sort of test the waters and see if you like something, and then you get really awesome things on your resume, whether you win or not. They're super non-threatening, highly learnable spaces, and yeah. I'm also, setting the stage for the thing I'm going to plug later on, so it's not all you, Lloyd. It's cool. What other announcements do we have? Perfect. Saw you blush for 2 seconds.
My name is Angela, and this is Kristen, and we wanted to let you and last year
committee and remark on any people who were in like, say tech or data science, it's marketing science, like with all of us. So we're actually part of a group called 500 Women Scientists, where we're going to have our own table. But I encourage anyone who considers themselves a scientist or a technician to march for science and get science funding.
It's in Denver, downtown Denver, April 14th, 8:30 to 1, stuff going on. And
Science job. Which is kind of like outside for in the same room.
Awesome. The 500 Women Scientists Boulder is also a really great Slack channel. If you guys do you guys accept that?
Yes, we all genders, ethnicities. Inclusivity is the thing. So yes, definitely if you're a man, we're not trying to do divorce.
All right, any other announcements before we move on to jobs? We've got events coming up. Job. Let's go to jobs.
Hi, everyone. My name is Eric Westerkamp, executive at Calvin Mines, a startup here in Boulder.
Oh, yeah.
We are a marketing intelligence platform that helps kind of grab data from a whole bunch of sources, integrate it with that platforms. We currently have a couple positions, Python programmer, or on the Python programming side and on the data science side. I also made that with somebody that just talked to potential.
And Ravi is your CEO, right? Raviv, sorry. Raviv is awesome. I haven't talked to him in a long time, that's why I forgot his name, so apologies. Yay! Tell him I said hi. Any other jobs? Where's Kelly? I'm just going to call her out. Yeah, and you're standing in the front.
My name is Kelly Kinnebrew. I have a startup that has been recently accepted in Microsoft's AI Accelerator. And it's so I need a developer. First needs to know machine learning. He has staffing to do, and we need some of those Microsoft developers who think they know everything, right? But they don't, right? So you're going to come to this small team environment. And so with machine learning, the last time I turned on chat about this, user interface is great, but for the MVP, not as necessary.
Awesome. Any other job announcements? All right. You have one. Bring it.
My company is probably going to be hiring for data scientists. I work in Denver. It's a financial services. Product partner that's current there. And here, that's partnership. That's Denver. Anything else? Next month.
Right on. Sweet. So for all of you guys that are introverts and decided that you just wanted to listen to any other jobs that are open and all of that other stuff, I want to let you know that every one of our speakers is available and looking for a job. Got that? Got that, Kelly? Speakers. Any other announcements? Got one.
I have a quick announcement, an event, Boulder Startup Week. Just a quick plug, May 14th through the 18th. It's really awesome if you haven't been there before. tons and tons, 30 tracks, I believe, 30 something. And I'm one of the captains of the data science track, and we have 6 awesome events planned. So just kind of a save the date, check it out. The schedule should be live in a couple weeks. And yeah, that's it. I'll just other things.
That second or third week of May.
The 14th to the 18th.
Awesome.
Okay, yeah.
Second and third. It's like right in the middle.
Yeah. 14th to the 18th.
Awesome. I have 2 announcements, so I'll jump in. What's that? Yeah, I can do both of them. Go ahead. You can go first.
So I just want to say I'm a grad student here at CU. I had I'm looking for a job. It's kind of the TLDR. I have experience in Python, data structures, and algorithms, all this kind of classic stuff, and then statistics, machine learning, my research is complete. So I want to talk to you. I'm interested in that. You too. Great. So talk to me. I'm interested in that.
Somebody buy this man a beer. All right, so I have 2 announcements. The first one is GoCo Colorado. This is their 5th year. It is a yearly statewide competition, and this year is a little bit different. So 5 different locations, just like before, but 2 teams will be chosen from each location to go to the semifinals. And unlike before, the 2 teams that win will get $2,500 right then and there. Then, after 6 weeks, they will present the rest of their work in the finals, and they have a chance to win 3 $15,000 awards. Now, all you have to do is have an idea that will help Colorado businesses that uses public data. And they provide all of the public data, and they will help you find your team and all of this fun stuff. The first year that it was going on, I was a participant. I am a proud number 1 runner-up, I should say. So we didn't win $25,000, but we got bragging rights for being the best of the non-winners. And the last 3 years, I was a mentor. So if you have any questions about how to really nail this thing, come and talk to me. The first one, I recommend going to Fort Collins. Denver is going to have a ton of teams. Fort Collins is going to have fewer teams. You are going to have an excellent chance of winning $2,500. All right. And my next one is the Lady Coders Conference, which is happening this weekend. It is just for women. There are all sorts of things going on. I know they've done this conference before, but I'm not sure exactly how many times. But the woman that runs this is amazing. She's on her 3rd startup, and just look up Lady Coders if you're a female and you're a developer interested in developing. All right. Are we ready for our first speaker? Question. 1 sec. Oh, just go ahead and announce it.
And they offer childcare at Lady Coders, so if you have your kids over the weekend, you can still attend.
Boom. Because Elaine knows what's up. All right, so without further ado, I'm going to have Ed White come on up. We get to do the awkward transfer.
Okay.
We need to come up with a dance for this transfer.
All right. Am I all set? And let me see the mouse. Do I have a mouse here or just here? There we go. Yeah, this will be good. All right. Good evening. Thanks for coming. So my name is Ed White, and my project is classifying mountains using neural networks. So I have a background in both business and computer science. I have an MBA in finance and marketing from the University of Chicago Booth School. I've then worked on Wall Street as a research analyst covering bank debt and bonds. I worked for some major institutions and some hedge funds. And then I moved to Denver, and I've been developing software for financial analysis and trading. And I decided to get my skills current, and I took the data science immersive at Galvanize, and all 4 of us just graduated a couple months ago. And we have to do a capstone to graduate, and mine was inspired by my love of hiking. So I don't know if you've ever noticed, but mountains can be named a mountain, like Green Mountain, or it could be a Mount Evans, or it can be a Pikes Peak, for example. So I wondered a few years ago, is there any rationale to the mountain, mount, or peak naming? So I Googled it, of course. And as far as I can tell, there's no official designation, but I did find that there was a college student a few years ago who did a statistical analysis, a multinomial logistic regression, and he looked at three numbers. He looked at the elevation of the mountain, he looked at the isolation, which is how far the peak is to the nearest peak, and he looked at the prominence, how high the peak is to the saddle. And he found there is a tendency that mounts tend to be high elevation and prominent, and mountains tend to be relatively low elevation and rounded, and peaks tend to be pointed, often with other mountains nearby.
Not sharing the screen. I need to fix that real quick. Sorry about that. We have a technical error here.
I'm gonna pause your time.
Okay. Where did it go?
There we go.
Okay.
We could just stare at that the whole time.
All right. So do I need to redo this one? Yeah. So
They heard you.
oh, they heard me. So the mounts, high elevation, prominent, mountains, rounded, and low elevations and peaks tend to be pointed and have peaks nearby. So this was done looking at the three numbers, the elevation, prominence, and isolation. My idea was to see if I could look at the photos of the mountains and use a convolutional neural network to see if I could do the similar classification of mountain, mountain, or peak. And while I was at it, I decided to also see if we could look at photos and figure out which state it is in. So to do a neural network, you need lots of data. And fortunately, I found a website listed, John, and the website administrator was very helpful. I've got nearly 50,000 photos for nearly 24,000 peaks. I had to deal with class imbalance issues. You can see I have far fewer mounts than I have mountains or peaks, and we in Colorado tend to take a lot of photos. These are like the top states for a number of photos, but we have a lot more photos for Colorado. So I had to do class rebalancing issues, upsampling, downsampling, that sort of thing. But basically what I did was, the prior guy did a statistical analysis on those three numbers. I redid that. I found that a gradient boosting classifier gave me the best. So the basic idea is to compare the results of the CNN with the statistical classifier. So there are different ways of constructing CNNs. I use this one because it worked pretty well, but basically the way it works is you input the photo as a multi-dimensional array of numbers, and it scans it for low-level features, curves, and vertical and horizontal and all that. And then it scans the output of that for higher-level features. And it goes through different things. Max pooling reduces the size of it. The dropout is a regularization to prevent overfitting and so on. And then you have two dense layers, which are basically your neural networks that do most of the calculations. The final part of this is an activation function, a softmax function, which basically just gives a probability that it's in one class or another. That's basically the answer that we're looking for. So here's what I did. This is a sample photo. After training it, I put this photo in and I said, is this a mountain or a peak? And based on the, does anybody recognize this, by the way? Tori's close. It's actually Grace, but it is pointed. So I'm going to guess it's a peak, and it is Grace Peak. And the CNN predicted there was a 69% chance it was a peak. So if it says more than 50%, we'll say it got it right. So then this is another Colorado mountain. Mountain or peak is what the question is. This is kind of a difficult one because it's kind of rounded. It's kind of hard to say how prominent it is, but I'm going to guess it's a mountain. Turns out this is Mount Evans. And the CNN also had difficulty with this. It only predicted a 49% chance of a mount. So this is another difficult one. Colorado or Utah? I usually think of Utah as like, you know, arches and reddish mountains and all that. So I would guess Colorado for this. but in fact, this is in Utah. And the CNN got it very wrong. It only predicted a 5% chance for Utah. And then finally, this one I think is pretty easy. Washington or New Mexico? This looks pretty sandy to me, pretty dry. I'm going to say New Mexico. And of course, it is New Mexico. So basically, as we typically do, we take our data and we split it into like 80% training data and then 20% tests. So this slide summarized the results of my test set on the various comparisons that I did. And so when I did a mountain versus peak, the CNN overall got it right 60% of the time. If you randomly guessed, you could be right 50% of the time. So it did a little bit better. On a three-way comparison, mountain or peak, you'd be right 33% of the time. Again, it was a little bit better, 41% of the time, but not too great. And if you remember, we did a statistical classifier using the three numbers. The statistical classifier did much better than the CNN. However, when I did the geographical comparisons, it did much better. Overall, you can see it did pretty good on the geographical. But what's really interesting about this is that if you look at these states, the ones that geographically are the most separated, it did the best on. So like Washington versus New Mexico, of the 5 different ones I have here, those are the ones that are farthest apart, both vertically and horizontally, and it did the best on that one. These two are similarly kind of far apart. It did pretty good on that. New Mexico and Utah are actually corner states. They touch at the corner. So it was not quite as accurate on that one, 64%. But Colorado and Utah are actually border states that are parallel to each other, and it didn't do much better than a random guess. On a three-way comparison, got 63%. It's better than 33% random guessing. It's basically kind of a weighted average of these results up here. So those are my results from the CNN. This is the technology that I used, and feel free to contact me for more information.
Did you upsample or downsample?
Well, it depended. Basically, you know, this needed to be upsampled. This downsampled. You know, this had to be downsampled. These I just, you know, I picked, like if I was comparing these three, I'd basically pick 5,000, make them all the same. So it just depended on how many were in each class.
I was just wondering, how does it downsampling work? I understand how the upsampling works, it's replicate and flip, but how does the downsampling work?
Well, let's say I had 7,000 photos and I wanted 5,000. I would basically randomly pick 5,000 out of the 7,000. That
Sort
is
of
simple.
like splitting into training versus...
Yeah, sort of, yeah. Downsampling is actually much easier. For the upsampling, let's say there's one where I had like 2,500 and I wanted 5,000. Another thing I could do is there are different ways of manipulating the photo. Like you could flip it horizontally so that you have like a mirror image of it, and you could create new photos that way to upsample. There's actually some libraries that you can do that automatically as well.
Any other questions?
Does the option we base this on no that everything?
No, I thought about contacting them. I don't really know if I know how to get a hold of them. This is online. You can see it if you want.
And a follow-up question. From the GitHub, so I can download this, and I put this into a VR application, and go around announcements, just kind of quickly decide.
That'd be interesting. I actually, you know, we had 2 weeks to work on this project, and it included everything from getting the data to writing the program. But one thing I wanted to do is create an interactive thing where you could actually upload a photo into it, and it would tell you. But I didn't get that far. But it could be done. Yes.
And let's do one last question. All right.
Great.
All right.
Oh.
So I'm just curious what the dollars actually use.
Definitely Python, and I used TensorFlow and Keras. Well, it's in Python, and we use TensorFlow and Keras. All right.
Awesome, thank you, Ed.
Thank you.
For all of our sustainability lovers, Amber, we have next. Everybody watches here.
I think I should.
Cool. That should be good. Cool. How's that? Everyone hear me? Cool. Great. Yeah, so I'm Amber Rivera. Thank you so much for having us here tonight. A little bit about me. I grew up here in Colorado. I spent the last 7 years working with data in the energy field. So first I was in the solar industry, modeling risk in an asset portfolio. And then most recently, I was working in digital analytics for a news site that focuses solely on energy issues, solar all the way to oil and gas and everything between. And we did a little bit of energy efficiency, but I hadn't had any experience in that yet. So I used my capstone as a chance to learn. And I approached data science from having a lot of experience with data analysis and different types of modeling, but I had never learned machine learning or done any predictive modeling. So I wanted to apply that to my domain. So just out of curiosity, how many of you have actually considered doing an energy upgrade for your own home that would be energy efficient? Okay, actually fewer than I expected in Boulder. And how many of you actually went ahead and did it? Okay, so that was, yeah, 3 and maybe 25% of those who put their hands up. Okay, so for everyone who didn't actually do one, but maybe you've thought about it, what are some of the reasons why you didn't go ahead and do the upgrade? Just shout them out. I don't own my home. Yep. Cost. Wouldn't have been efficient. We should talk after this. Very interesting. Yeah, that's true. That's possible, especially if your home's newer. There might not be any room to upgrade. So there's a lot of reasons why. But be able to predict. So I worked with a company called Radiant Labs, who works here in Boulder, and they're actually doing this in a different variety of ways. But they weren't using any predictive. I was lucky. Some information. So they have a tool that they've built for energy auditors called Snug Pro, and that's collected some of the building characteristics. So how many rooms the house has, all the things that you could think of without actually talking to the homeowners for the house. Census information, obviously we can all grab that, and then simulated energy use. So this was pulled with a tool called ResStock from NREL. So it's a physical simulation model that takes the home characteristics and position of it geographically, and runs it through a simulator to see what the energy usage would be with different assumptions. So it looks at the pitch of the roof and the location and how many people might live there, that sort of thing, energy usage. So I didn't actually have real utility bills, but I had a pretty smart assumption for this. A little bit about Radiant Labs. They are actually pretty good already at doing this themselves. They built their whole business models around it. Does anyone know Labs, by the way? Yeah, okay, cool. Really great guys, working in Clojure and Node.js and a little bit of Python, and now a little more Python after the project. So this is a platform that they built for City of Boulder and other city clients who are trying to identify homes that'll be good targets for energy efficiency incentive programs. So what they do right now is essentially filter down based on different things. So what you'll see here is home equipment and the likelihood that that equipment will need to be replaced based on some modeling of their own that they've done. So they can filter on this tool. You'll see the darker areas already indicate where someone's home, their furnace might be going out and it might be time for an upgrade. So just using what they already know about the industry, they're trying to manually or using a heuristic predict when somebody might be a good target for an update.
But the data came to me in CSV files, so I get to start from scratch. And I'll tell you a little bit about it real quick. So I had 360 features for every single family detached home in the city of Boulder, so just city, not county. And it was mixed data types. So again, all the things that you might be able to think of, whether it has a garage or not, lots of different things, different home ratings. I actually had some consumer data that we thought would be very, really, 2 minutes? Had some consumer data that we thought would be really helpful. I'm going to speed up a little bit here. The features, there's a whole lot of collinearity, so I knew I would need to get an algorithm that would be pretty robust to those correlated features. I created some new stuff, so different proxies for social influence and number of per instance purchase. I also had class imbalance issues, so in my case, and I'll just, if you know anything about machine learning, I'm going to foreshadow something here. I actually had more success downsampling to 50-50. And tried a lot of other things. In my experience and what we had learned, SMOT and random oversampling tend to work better, but not in this case, and I'm learning that not so much in the wild. So I looked for the best classifier using recall. So you use that when you want to minimize false negatives. So if Radiant Labs doesn't go talk to a home that actually would upgrade, they're leaving money on the table, right? Ends up that it doesn't cost them very much to talk to the home, but the potential revenue is a lot. So we don't want to miss any of those. So I optimized the model with recall. And lo and behold, I think it's pretty common that in a lot of supervised machine learning tasks, random forest does pretty well. This is a single decision tree, and we can talk about random forest more after. I'm sure most of you are a little familiar with it at least. And it turned out, and yet it didn't do very well. It had 0.55 as the recall score, which is very moderately predictive. Here's some of the feature importances. So year built, room count, bedroom count, last sale price ended up being the most useful. That consumer data didn't help at all, it turned out. The propensity for someone to do an energy efficiency upgrade, which was very interesting. Even though the model didn't do very well, we learned a lot about some of the data they were paying for and its predictability for their needs. So I'll just show you briefly. Here's a subset of the homes from the training set. Here's all the true positives, all the false positives, and then everything that the model incorrectly predicted. And so yeah, I mean, you can see again, that's just visually what 0.55 recall looks like. But I think that was really good for me to find in my first project. A little bit deeper, right? So I actually wanted to quantify, well, even if we had that weak of a predictor, what could the implication be if they layered that into the way that they target homes already? And so we did an analysis kind of just looking at business costs, expected value is what it's called, and found that it could potentially increase by 13%, which is, we haven't put it into production yet. We're not sure. It's still pretty modest. But I think it was really good to just get them thinking about predictive modeling, and they are actually going to take it and put it into their as a feature, so just the score and the rank of those households when they essentially filter down the homes and then give them to contractors as leads. So a lot of other ways that this could be done. I really wanted an interpretable model, went the supervised route, but my next would be to look at this with a neural network, obviously, a lot stronger. But I think the biggest thing I learned here is that that data didn't have encoded within it any behavioral information. So there are definitely bigger companies in Boulder that have all that kind of information or looking into this kind of stuff. Maybe you work at one of those. But pulling in a lot of behavioral information. If someone's house and the physical characteristics are right, but they're sending a kid to college that year, it might not make sense, right? Everything in the world could align and it won't make sense. So, yeah, you can find more information here. There's my stack. And yeah, I'd love to talk to anyone more about it afterwards.
Did you have a chance to look at anything around appraisals and how they hold for a house or houses?
Yeah, so I didn't look at that specifically. I had both of those pieces of information. Appraisals would just be, we didn't have appraisals like current. We had last sale price and also the other piece of data. They both just went into the model as features that might predict the target. So the target really was, will they or won't they upgrade overall with all those features? They have the data. Yeah, I mean, they could look at it that way. I think what you might be suggesting is, could you build a model that had, you know, appraisal and tax and less sale price and that sort of, and number of permits pulled, and just put those in as the features that it might predict off of? And if that was powerful, like, absolutely. With limited time, we, you know, the really shortest path of least resistance would have been putting it in a neural net and just letting that do all the regularization. It can, you know, it's the most powerful. But I just did random forest because we wanted to be able to see which of the features were most predictive. But those didn't crop up as, you know, to the top. So, but there wasn't a whole lot of signal. So even if you saw in those feature importances, a lot of those very, very small numbers, right? But sort of that recursive feature dropping would be another way to kind of go about trying to figure out the noise in the data, see if we can make it stronger.
More questions?
Can you talk a little bit more about the time aspect of, you know, with the data? Yeah, the different aspects of that.
Yeah, totally. So the 2 data sets I had were information that had been pulled in September 2017. So those were like the majority of the features for each observation was a home. And then the other data set I had was whether or not the house had ever participated in the energy upgrades program in Boulder. So those were all the positive classes, right? So the number of, so if those homes were in that data set and that upgrade was prior to 2017, you know, when that data was pulled, I kept them, marked them as a yes for target. Otherwise, if there was leakage, I, you know, got rid of them. So, yeah, great. Yeah, I guess that makes sense. But
Any other questions? Awesome, thank you, Amber. All right, up next we have David. Yes! This is a constant struggle.
Yeah.
Making sure that
And you spelled it right too, which doesn't happen very often. All right.
Hello, everyone. You hear me? Hi, so my name is David. I have a background in financial research, and I'm also very interested in healthcare, and I had an amazing opportunity to work with Health for this project. They're working on taking healthcare and environmental data and putting it into an interactive so that you can see the between chemicals and other health issues, you know, health outcomes. So I decided to do my project on lung cancer to try and see if I could pull public data to accurately model the incidence rates of lung cancer level. A little bit about why I chose this. There is obviously a huge problem with lung cancer. It's one of the causes of death in the world, and it's we know that there's a strong linkage between smoking and cancer, of other relationships, including some chemicals like asbestos and lung cancer, as well as general health. So my kind of goal was to take a lot of these already shown to be important factors related to lung cancer and see if I could use public data to build an accurate model. So just kind of once I gathered all the data, I was left with about 150 counties, I believe. And this is all the counties. You can see the 95% confidence intervals, and on the y-axis, the incidence rate per 100,000 people. It's just a standard way of measuring a lot of these diseases. And you can see that the main important thing here is that there are some counties on the left in California that have incidence of around 30 per 100,000, while there are others in Kentucky with around 150 per 100,000. So there's just a massive difference in the lung cancer incidence rate across different counties in different states. So once I gathered all my features, I had to select the ones that were most important. And in order to do that, I used primarily the Bayesian information criteria, the BIC. And essentially what that does is it maximizes the likelihood of the data, regularizes it based on how many features you're using. So basically, using all the features could provide me with the highest likelihood, but it would likely overfit the data. So that's what the regularization parameter is for. And then in red, you can see the variables I used that gave me the lowest BIC score, which is what you're looking for, which maximizes the BIC criteria. And that included variables like smoking, PM2.5, which is particulate matter type of air pollution, general air quality index, and radon levels. So these are all the models I used, and I started with the pooled and unpooled models. The unpooled model basically fit a separate regression line for each of the counties. The pooled model fit a single regression line for all the counties. It's not surprising that that one did the worst. And then the multi-level models, I'll get into more detail, really what I focused on, but the one that focused on grouping all counties together definitely worked the best, and modeled the incidence at about 95 or 96% accuracy, which I was very happy with. And I'd like to kind of just break that down a little further. So this was between the two multi-level models. One grouped all the counties together, which is the one shown here, and the other only grouped counties together that were in the same state. So essentially here, these are the point estimates for the one that grouped all counties together. So essentially what this is doing is it's fitting a separate regression line for each county, but it's including the similarities that all counties share, things that I didn't include as predictors. They could be laws on pollution. They could be, just a whole number of things that are just hard to use as individual predictors. So this is Warren County. And then this is the state level grouped on top of it. So as you can see, the point estimates on average are just shifted up towards the dotted line. The green dotted line is the mean value for the state of Kentucky. So that really illustrates the difference between the two models. Since Kentucky, out of my data set, had the highest incidence rates, a generally lower lung cancer incidence county, Warren County in Kentucky, they tended to overpredict the number of lung cancer cases. And basically, this is just kind of extended for all the different counties. It's those two same hierarchical models, but now you can just see the 95% confidence intervals in green for the state grouped, as well as for the in blue, the county level. And these are the dots are the mean values for all the years, and those confidence intervals are all the would contain 95% of the individual yearly values. So I think I did pretty well grouping all the counties together to draw those similarities from. But I think in the future you can definitely incorporate, especially for certain predictors. Let's say there are certain predictors where looking only at that state would make sense. You can kind of mix and match the two approaches. Also, there are things that I didn't look at, including racial differences between counties and other health factors. And so I'm very excited to include into this analysis in the future. And then to really make predictions into the future as opposed to just modeling the past data, I would need more data points per county. I was only working with 10 or 11 years versus to use something like a neural net, I might need multiple values per year per county in order to do that. And with that, I'd like to open it up for questions.
Can you talk a little bit about where you got your data? I'm really interested, for example, on radon.
Yeah, so the main data source I used was the NIH SEER cancer data. I needed to just sign a research agreement. They sent it to me in 20 minutes. The rest of it was public data, and some, like radon, took me a long time to find. That one was actually posted by a Columbia professor on his own personal website, and my professor told me about it. So I looked for a long time for radon data. This is from the late 80s, early 90s, but the effects of radon on lung cancer take 10, 15, 20 years. You know, I didn't be effective, but it was one of the, less than smoking, but it was included in the Bayesian information criteria score as the best model, so I ended up using that. And yeah, the rest of the data was sourced, almost all just publicly available data.
All right, another question.
Were you able to look at occupation? So like you saw people on the whole line, things like that, was very appropriate?
That's an interesting idea. I did not look for data. I guess you'd have to maybe look at the percentage of workers in certain industries, maybe. That could be something that would be useful. The main ones that I wanted to include that I didn't get to were like the socioeconomic ones, like poverty and income, and then also just general like health factors like alcohol consumption that could also have an impact on lung cancer. But there's certainly a lot that I'd like to include in future iterations of this project.
Any other questions? Awesome. Thank you, David.
Cool. Thank you so much.
All right, are you guys ready for our last speaker? Like super ready?
Yeah, I'll hold this.
So my extrovert is now here.
Was that good? Oops, that's my pen.
All right, up next we have Sarah Lewis. About mountain biking.
Thank you. Hi, everyone. My name is Sarah Lewis. I was a high school math teacher for the last 10 years, teaching everything from Algebra 1 up to AP Calculus. I wanted a new challenge, so I applied for the data science program, and it was a lot of fun. And I'm here tonight to tell you about my mountain bike trail finder. As a mountain biker, whether you've been riding for years or just starting out, you're always looking for the next trail to shred. The best way to find a recommendation is to simply ask riders in the parking lot of your favorite trailhead. But upon being told that a trail unknown to you is totally epic, you'll often wonder, well, is this new trail mostly fast and flowy or more rocky? Is it a loop lollipop or will I need a shuttle ride? Can I bring my dog, and if so, have her off leash? MTBproject.com does a great job of answering all these questions for you when you search for a specific trail. But you're still left wondering, what trails have I ridden are like this new one? Wouldn't it be great if you could get a recommendation for a trail based off of trails you already know and like? My capstone project in the Galvanized Data Science Immersion Program, I created a website that recommends trails to users based off of trails you already know and like. Using MTB Project's API, I was able to gather the data that MTB Project makes available to their users on 26,752 trails in all 50 states and the nation's capital. I did feature engineering to quantify my categorical values. And then I created this heat map to get an idea for the correlation between features. The darker red and blue boxes tell me that the features most highly correlated with each other are length, ascent, descent, difficulty, user rating, and type of trail. So let's take a look at a subsample of our data. Patasso and Marshall Mesa are trail in the Boulder area. Most local riders would agree are very similar and great for beginners. Apex Park Tour is a trail in the Golden area that most local riders would agree is not similar to Patasso or Marshall Mesa. But the question is, how do you actually quantify that? Well, first, we need to prepare the data. You can see here that a difference of 3 miles in length is much different than a difference of 3 feet in ascent. Therefore, I scaled my data by subtracting each feature value by the feature mean dividing that difference by the feature standard deviation. I then put those values into vectors that represent each trail, and now I'm ready to measure similarity. Based on investigation and intuition, I chose the cosine similarity metric to determine similarity between trails. As you can see in this two-dimensional space, cosine similarity metric measures the angle between the vectors, not taking into account their magnitude or size. In essence, cosine similarity measures the ratio between my trail's features, not just how big or small they are. A cosine value closer to 1 means that those two trails are similar, whereas a cosine similarity value closer to -1 means that they are dissimilar. Therefore, it's no surprise that the cosine similarity value for Pitasso and Marshall is 0.99, while the cosine similarity value for Pitasso and Apex Park is -0.41. Now, Apex Park Tour is one of my favorite trails in the Front Range, but I'm headed to Moab, Utah next month to go camping and riding. So if I like Apex, what should I ride in Moab? Well, let's go to MTB Trail Finder to find out. Okay, so I'm going to go to recommendations based on trails you like. Select a state that I've ridden in, Colorado. Select the trail. I'm just going to, go to Apex Park. Where am I going? I'm headed to Utah. And then specifically Moab. Recommend me. Okay, so you see I get a list of many trails, but the one that is most similar to Apex Park Tour in Moab is a map. The summary of that trail is that it's one of Moab's classic rides, featuring steep drops, big exposure, great views, and a rugged climb. Sounds epic. The problem is, one of my friends coming on this trip prefers trails in Pitasso Preserve. She'd be pissed if I dragged her down a massive back. So, well, let's see. Colorado. She loves that Pitasso. Still no. All right, so what should she ride? Monitor Merrimack. You can see here that the features are pretty similar to Pitasso Preserve. It's a great beginner intermediate introduction to Moab Slick Rock. I think she'll like it. If I click on the link, it'll take me to the projects page where I can get her a full description of the trail, and most importantly, I can get driving directions to know how to drop her off on my way to Massaback. So please go to mtbtrailfinder.com for all your trail recommendations, and most importantly, do not forget to wear a helmet. Thank you very much.
All right, what epic questions do we have for Sarah?
Yeah.
I was just curious, being talking to people, they're based in Denver, and I know that they Rachel, Chico, I think her name is, lives in Boulder, so there's a lot of engineers on the team.
Yes, this is a question I've asked myself many times. The problem is, if on the FAQ of Mountain Bike Project's website, they say that their API is not intended to recreate a data set, and I kind of did that using Python programming. So once I get a job, I actually fully intend to tell them about it, and actually one of their web developers recently hired is a friend of mine, and he said he'd like to help me with their website. So hopefully it won't be a problem, and I never gotten in trouble for making 20,000 hits to their website, which is what I did. So.
And you didn't crash it.
No, well, I always did it overnight, and it was in the off season, so I figured it was okay. But yes, I fully intend to tell them about it. I'm really excited too.
Tell them about it.
I was thinking that. I was, and Well, no, I can't move, but I do know that they have an office in the Boulder area for their adventure projects, like you mentioned. But I've seen that they're only hiring web developers. Yeah.
Will you give us a follow-up talk on this after they hire you?
Yeah, and jobs at REI are all around. So, provide.
Other questions?
I'm still learning about new things, and when you're talking about the cosine similarity, I'm particularly interested. You have multiple variables, and so are you looking at a multivariate space, and so looking at like the factors in the multivariate space come out?
For sure. Like this diagram is just of a two-dimensional space, but this formula shows that you take the dot product of those two vectors, essentially multiplying each feature by itself and adding it up. And then you're dividing it by the magnitude of each feature, which is essentially the square root of the sum of the... I can write that out for you if you'd like to, or show you actually how to calculate these specific ones. But yes, it is multidimensional, or specifically 5 dimensions.
Just a follow-up question on that, because I was wondering, because you do a standardization step just before you calculate this one. Is that standardization step not redundant if you use this distance measure?
Yeah, because I'm dividing by the magnitude. That's a good question. I didn't check to see. I didn't compare. I mostly did the standardization anyway, just as like a safeguard. Yeah, good question though.
Earlier this year, I heard about ski run recommender.
Yes, Karen. She made that. Oh yeah, so Adventure Projects, as you mentioned, is REI's app. They have a mountain bike project, they have a hiking project, they have a trail running project, they have a ski project. It's awesome. And so you could I imagine that they, for each user, allow access to the API for any of those sites, and I imagine that you could recreate this for any of those. I know Ski Run Recommender, my friend Karen, she had to pull in her data from lots of other sites, and she had to do a lot of web scraping, and Adventure Projects makes it so easy with their API.
Awesome. Last questions? One more.
Do you have any data to support significance or the accuracy of the model you created? That says, oh yeah, it's really like
Yeah, that's a great question. I personally have ridden over 50 trails in the state of Colorado and at least 20 in Utah. And I have a lot of lady shredder friends who contributed to the opinions of my website, not just how it looks, but also friends who've ridden it, North Carolina, Oregon, all over to determine how good is this. But it's really just a subjective opinion. I went to Taos, New Mexico a few weeks ago to ride, and I used my own website to get a recommendation. And the trail that I rode was really similar to North Table Mountain that I was using as my trail. So yeah, it is subjective. But I highly recommend that you try it out and see what you think. Tell me about it. Because I can change the metric that I used, but I found cosine similarity to be the best one.
Have you thought about how it would be possible to do this but on the system? That I'm going to do such as line how you could work that to say, this is my trail, that's the trail I'm going to ride in. Whereas multiple variables and multiple.
Do you mean like how,
like at the Green Mountain Loop in Golden, there's like the Summit Loop versus like the whole trail system. Oh.
Okay, so another example would be you go to Breckenridge, your friend does a race, and like, oh, that was 6 trails all connected to create this 30-mile village for a park. And then you that, where it's like, okay, I'm going to go to Oregon and do those that race.
Sure. So actually, one of my features was type of trail, and there are 2 types of trails. There's a trail like, you know, like a 1-mile section that's like at White Ranch. The Belcher Trail is like at that trail system amongst many other trails. But then there's also featured ride, and a featured ride is a connection of trails, and of course they're usually longer. So you can see from my website, like it'll tell you if you chose a featured, if it's a featured ride or not. So you can choose a featured ride, like Batasso Preserve is a featured ride because it's this specific ride. If we look at it, it's a connection of trails. And you can see actually that the ones most similar to it in Moab are also featured rides. But that's not necessarily always true. Like there might be a trail. And yes, mountain bikers, when you go on a ride, you're not just looking for one trail, you're looking for a featured ride. Yeah.
Awesome. Thank you so much, Sarah.
Yeah, thank you. Maybe that's down.
All right, so my assumption is that there's more than just Patty here that is
Gotta get over here.
Raise your hands. This one is
As long as she wasn't in that, that's cool. Okay, cool. Well, they couldn't